This week we want to take a look at our limit again, and we want to compute end behavior. As x approaches infinity or negative infinity, what's happening to f of x? Let's start with something that we're familiar with, a polynomial and its end behavior. We can use degree and the leading coefficient to help us find the limit as x approaches infinity or negative infinity. So if I take a look at question number 1 here, I have the function 7 minus 3x squared plus 4x to the third. So even though it's written backwards, I can see that my degree is 3 and that my leading coefficient is a positive 4. So if my degree is odd and my leading coefficient is positive, then I know that my graph is going to start low and end high. So it might look something like this. So if I'm asking myself what's happening to this function as x is approaching infinity, as x is getting larger and larger, going to the right, my graph is shooting up. So that means that my limit would be positive infinity as x approaches infinity. Let's look at question number 2 now. Another polynomial function. We want to find the limit as x approaches negative infinity of a negative 8x to the fourth plus 3x to the third minus 10. This time we're dealing with an even degree of 4 and a leading coefficient that's negative. So it might make an upside down u or it might make an m. And as we look at what happens as x approaches negative infinity, as I move to the left, my graph is shooting down. So it's approaching negative infinity. Unfortunately, we're not always going to just find the limit of polynomials. We also want to find the limit of rational functions. So let's look and see what happens to a rational function. If we're given f of x is equal to 1 over x, and I plug 100 in for the x, then 1,000, then 10,000. Or maybe on my negatives, I plug in a negative 100, a negative 1,000, or a negative 10,000. We're getting closer and closer and closer to 0 on both ends as x is getting bigger and bigger and bigger. We can look at the graph of this. Our exponential function here is going to have asymptotes of the y-axis and the x-axis, and it's going to make two L-shaped curves whose boundaries are the x-axis and y-axis. So I can see that the limit as x approaches infinity of my 1 over x is always going to be equal to 0. Same thing is going to happen, the limit as x approaches negative infinity, it's also going to get closer and closer to 0. We can use this to help us find our limits of our rational functions. Whether it's a 1 over x or 2 over x squared or 10 over x to the 7th, any constant over an x, his limit is always going to approach 0. For rational functions, in order to find the limit, we're going to multiply the numerator and denominator by 1 over the highest power of x in the denominator when our x is approaching infinity or negative infinity. So we only do this for our problems where our x is approaching infinity or negative infinity. We can use the theorem on page 132, which in your calculus book you don't have, but it says that I can split the limits up into individual problems. So I can find the limit of each individual item and then put it together. Looking at question number 3 here, we want to find the limit as x approaches infinity of 2x to the third minus 4 all over a 5x plus 3. So since my x is approaching a positive infinity, it says that my rule is that I want to multiply the numerator and the denominator by 1 over the highest power of x in the denominator. So in this case, for question number 3, I'm going to multiply the numerator and the denominator by 1 over x. Since my highest degree in my denominator is an x to the first. When I do that, and I distribute my 1 over x, I'm going to take 1 over x times 2x to the third is going to give me a 2x squared minus negative 4 negative 4 times 1 over x is a negative 4 over x. Then I'm going to do the same thing in the denominator. 5x times 1 over x is 5, plus 3 times 1 over x is 3 over x. So we can find the limit of each individual item. The most important ones are to start with the constant over x. So I'm just going to go ahead and rewrite my 2x squared minus, I can find the limit of my negative 4 over x as x approaches infinity. As I keep putting a bigger and bigger number into that denominator, that fraction is going to get closer and closer to 0. Same thing in the denominator. I have 5 plus my fraction of 3 over x. As I plug bigger and bigger numbers into that denominator of x, that fraction is going to get closer and closer to 0, which means that I'm left with 2/5 x squared. So I can either think about plugging infinity in, or I can say, hey, I'm left with a positive coefficient and an even degree, which means that it's going to be a parabola shooting up in both directions. And if x is approaching positive infinity, as x is getting bigger and bigger, my graph would also be approaching positive infinity. For question number 4, we want to find the limit as x approaches negative infinity of 5x to the third minus 12x plus 7 all over a 4x to the fourth minus 1. So if I take a look at my denominator, my highest power of x is x to the fourth, which means that I want to go ahead and multiply my numerator and my denominator by 1 over x to the fourth. When I distribute my 1 over x to the fourth to all parties in the numerator, I'm going to end up with a 5 over x minus 12 over x to the third plus 7 over x to the fourth. And in the denominator, I'm going to be left with a 4 minus 1 over x to the fourth. As I look at taking the limit of each of my individual items, any constant over x as x approaches infinity or negative infinity is going to get closer and closer to 0. So I'm going to have a 0 minus 0 plus 0 all over 4 minus 0. So if I simplify this down, I've got 0 over 4, and 0 over any number is 0. Now you do want to be careful. If you are approaching a negative infinity and your exponent is odd, you want to make sure you include a negative in there. But since my exponent was an even of x to the fourth, I didn't have to worry about including a negative. Number 5, I've got the limit as x approaches infinity of the fourth root of my fraction. So what we can do on this guy is, since I'm applying one function to the other, I can go ahead and remove my fourth root and put it on the outside, apply the limit to the inside, and then take the fourth root of my answer. And I can do that since my fourth root is being applied to that whole function of 3x squared plus 5x minus 6 over 16x squared plus 1. So now taking a look at my problem, in my denominator, my highest power of x is an x squared. So I'm going to leave this fourth root out in front. And I want to multiply my numerator and my denominator by 1 over x squared. So when I do that, I'm going to go ahead and move over here to the left. We're going to have the fourth root of the limit as x approaches infinity of a 3 plus 5 over x minus 6 over x squared all over 16 plus 1 over x squared. We know that any constant over x is going to approach 0. So if I take a look at what I'm left with, I'm finding the limit as x approaches infinity of a 3/16, which would be 3/16. And if I have the fourth root of 3/16, then I can go ahead and simplify that down to the fourth root of 3 over, remember that 16 is 2 to the fourth, so all over 2. Now for number 6 here, I can't remove that square root because it's not over the whole function. It just belongs in the numerator. For number 6, if I take a look at the highest power of x in the denominator, notice that I have an x to the first. So if I have an x to the first, then I'm going to multiply by a 1 over a negative x, since I'm approaching negative infinity. Because my exponent is odd, I have to include the negative. So I'm going to have a negative 1 over x. But I don't want to multiply the numerator by a negative 1 over x, because that's not going to help me at all. I'm multiplying a number outside a radical with a numbers inside a radical, and I can't do that. So what I want to do is I want to ask myself, what's another way of writing my negative 1 over x with a square root so I can do my multiplication? Well, I can rewrite this as the square root of 1 over x squared. So if I think of the 1 over x as the square root of 1 over x squared, and notice I don't have to worry about the negative since my x is being squared, then I'm going to have in the numerator the square root of 1 minus 2 over x plus 3 over x squared all over negative 1 minus 5 over x. So I know that these guys all go to zeros. And if that's the case, I'm going to have the square root of 1 over negative 1, which is negative 1. So for our problems as x approaches infinity or negative infinity, if we go back to the top, if we're just looking at a polynomial function, we want to use our end behavior. If we're looking at a rational function, a fraction, then we want to multiply the numerator and the denominator by 1 over the highest power of x in the denominator. And again, remember this is only for when I am having an x that approaches infinity or negative infinity.